One of the key steps in your assistant's development journey will be deploying your assistant in a production environment. In this episode, I would like to cover the key things you should keep in mind as you go through this process. For that, let's have a look at the architecture of rasa-plus because it will give you a better understanding of the key components that you will have to think about as you are deploying your assistant in a production environment and what kind of cloud services will be necessary to achieve that. Your deployed assistant will depend on a number of cloud services that you will need to monitor to make sure that your assistant operates successfully. Some of them are required, some of them are optional. For all of the components, you have a number of cloud services you can choose from, with the most popular being AWS, Azure, and Google Cloud Services. You can check out the rasa-plus documentation for a more detailed list. Now let's go through this architecture step by step. Model storage is a cloud service where the trained model is stored. Models can be stored in different places after you trained your assistant. Upon initializing or restarting your assistant, rasa-plus will download the trained model and read it into the memory. You have lots of different options for where the models can be stored, from disk storage, remote server, or cloud storage options like Amazon S3, Google Storage, and others. The lock store is needed when you have a high load scenario that requires the rasa server to be replicated across multiple instances. It ensures that even with multiple servers, the messages for each conversation are handled in the correct sequence without any loss or overlap. Your assistant's conversations are stored within the tracker store. Rasa provides implementations for different store types out of the box, or you can create your own custom one. You have quite a few options to choose from for the out-of-the-box tracker store implementation, from SQL, Mongo, Dynamo, or you can also build your own custom tracker store. You also have the Secrets Manager component. The HashiCorp Vault Secrets Manager is integrated with Rasa to securely store and manage sensitive credentials. The NLG server in Rasa is used to outsource the response generation and separate it from the dialogue learning process. The benefit of using an NLG server is that it allows for the dynamic generation of responses without the need to retrain the bot, optimizing workflows by decoupling response text from training data. Note that the NLG server is an optional cloud service that you have to create and deploy yourself. The Kafka event broker in Rasa is used to stream all events from the Rasa server to a Kafka topic for robust, scalable message handling and further processing. An event broker serves as a link between your active assistant and various external services that handle data from conversations. It sends messages to a message streaming service, often referred to as a message broker or message queue. This enables the forwarding of Rasa events from the Rasa server to other systems. One of the easiest ways to deploy Rasa assistants built with Helm in a production environment is using container orchestration systems like Kubernetes or OpenShift. Here, Rasa gives you two options. If you aren't familiar with Kubernetes, you can use Rasa's managed service, where Rasa's team will take care of managing the Rasa platform for you and will allow you to move faster and develop your assistant more efficiently. Alternatively, you can use Helm chart, which will significantly simplify the deployment process for you. Rasa's documentation contains a very detailed walkthrough of how you can deploy your assistant using Helm chart. And last but definitely not least, as you build your assistant and deploy it in production, you have to make sure that you have CI/CD, continuous integration and continuous deployment process configured for your assistant. This is extremely important because it will make sure that you or your team members don't introduce breaking changes into your assistant as you improve it. This will also make sure that as you make updates to your assistant, they don't intervene with the performance of your assistant in a production environment. Continuous integration, CI, is the practice of merging in code changes frequently and automatically testing changes as they are committed. Continuous deployment, CD, means automatically deploying integrated changes to a staging or production environment. Together, they allow you to make more frequent improvements to your assistant and efficiently testing and deploying those changes. There are many CI/CD tools out there, such as GitHub Actions, GitLab CI/CD, Jenkins, and Circle CI, and others. We recommend choosing a tool that integrates with whatever Git repository you use. If you would like to use GitHub Actions for CI/CD, you can find an example configuration of CI/CD using GitHub Actions on Rasa's documentation.